Join the conversation.
Join the conversation.
You're with Cape Talk.
My name's Dan Corder in for Clarence Ford, but Clarence here or not on Views and News. It is just after 9:30 on a Friday, and so we welcome our very own naked scientist, Dr. Chris Smith. Dr. Chris, nice to meet you for the very first time. Long-time listener, you have no idea, Dr. Chris Smith, how difficult it is for parents to try to explain what it means that there is a naked scientist on the radio on the way to school. Like, you really, like, I'm the eldest of five, and it's an intergenerational, Dad, what does that mean? Is his nudity somehow contributing to his scientific process? Is clothing some kind of inhibitor? We know that the eureka moment happened naked in the bath. Is it part of his system? Is that how he's at Cambridge? Is that how I get a Rhodes Scholarship? Please explain to us what is happening here.
Yeah, I suppose we're following in the footsteps of Archimedes, as you say, the first eureka streaker, as he was known. But very good morning, Dan. Nice to talk to you from, I think Chicago is supposed to be the windy city, but today it's Cambridge. My goodness. Okay. We've recorded a Guinness World Record wind speed, not here, but actually off the coast of Ireland. They got 114 miles an hour, which is a record for our climbs just today because of the arrival of big storms. So very, very windy, very, very cold. But you're warming things up for me this morning. Nice to talk to you.
I'm doing my absolute best. I'm very good at doing that because I know that Port Elizabeth, or Gqeberha now as it is rightfully called, is called the Windy City in South Africa, but it's actually Cape Town. I don't know where the City of Mothers thing came from, but I'm sure someone's going to tell me on the WhatsApp line now. I've always wanted to know if you really don't know the questions before they're asked to you live, and I'm thrilled that you don't know the questions that we ask you live. So if you have a question for the Naked Scientist, get onto the WhatsApp line and let us know right now. I've been encouraged by the lovely Amy Ray producing for Clarence Ford's shows to ask the first question from myself. And to the Naked Scientist, I'm going to take this opportunity to ask you one of my favorite stories from early scientific research that I still don't fully get. How did, whether it were the Egyptians or people in that area of the world many thousands of years ago, or a handful of thousands of years ago, how did they put, as far as I understand, sticks in the ground and use some shadow to figure out that the world was round? How does that even happen? Me today, with my NSC pass, which was fairly decent, good enough to get into UCT, would never be able to, with all the technology that I have, get to that conclusion. How did they figure out that the world was round with, as far as I can understand, sticks, the sun, and some maths?
I think you're referring to the story of Eratosthenes, who was the philosopher who did the experiment. And by chance, where he was in North Africa, someone had dug a well, and someone noticed that at midday, the sun shone straight down this well. So he knew the sun had to be dead overhead at that point. He then measured a distance away from the point where the well was and stuck a stick in the ground and got the shadow from the stick. Now, if you draw a circle on a piece of paper representing the Earth, and a notional line representing the well, which must be the path of the sunlight at midday down towards the centre of the Earth, then you go a distance around the circumference of the circle and put another line, which is where the stick is, and pretend you've got a shadow there. There's going to be a shadow that's at a different angle because the stick is not with the sun directly overhead, it's at a distance away. If you trace that line down to the centre of the Earth, you find they will meet at the centre, obviously, but there's going to be an offset, which is the difference around the circumference that the stick is. And you can use that angle, which the shadow casts from the stick, to work out what the angle at the centre of the circle is, what the size of your segment is, effectively. And that tells you, if you know what that size is, you can work out what the rest of the circle must be, and he was able to therefore work out the radius of the Earth and therefore its circumference from standard geometry. It's amazing. He got it nearly right, and given he was working in such early times with such primitive data and such primitive instruments, it's absolutely amazing. And there have been other giants who've done things like this. There's an astronomer called Rømer who was watching some of the moons of Jupiter, and watched one of those come flying into view and then disappear, flying into view, disappear. He was able to work out the actual distance to Jupiter based on the time it was taking the light to get to us from this moon appearing and disappearing when it should be appearing. They knew what the orbit was, and there was a difference in time. He worked out the reason is that sometimes Jupiter's on the same side of the solar system as the Earth, and sometimes it's on the far side. And that difference in the arrival time of the moon compared to when it should have been appearing was the time it took the light to travel across our solar system, so he could calculate the speed of light. It's amazing. And he was nearly right.
Fascinating. That is absolutely extraordinary. Right, that's how good the Naked Scientist is. Let us know your questions. Anything under the sun, even if the sun is being used to work out that the flat earthers are wrong. I want to ask you, Dr. Chris, if you get questions a lot about skincare routines because you are the Naked Scientist. We've actually got a few this morning. I think a lot of people think about the skincare routine they would have if they didn't wear clothes. So from Anne, there's a question which says, if you use exfoliators regularly, can this eventually remove your fingerprints? Dr.
Well,
Smith.
you can scratch off your fingerprints, Anne, because I've done it, not for any nefarious reasons or to stop the police identifying me, but just because I was in a swimming pool and I noticed that there was some green patches on the bottom of the pool. So I thought I'll scrub those off. And it was at the bottom of the deep end, so I sort of weighed myself down a bit and didn't have a scrubbing brush. I just used my hand because it seemed to be doing quite a good job. But when I surfaced, I found that I had removed most of the fingerprint patterns from my right fingers. And I couldn't unlock my phone. And I didn't have a code. I had to use the fingerprint thing, so I couldn't get my phone for a week. It was great for my sort of social media distancing that I did that week. So you can do that. But the thing is, the skin is an amazing organ. It's our biggest organ. And if you're a rhino, your skin weighs about 1/4 of a ton, just your skin. Wow. It's an amazing thing, but it has an extraordinary regenerative capacity. Every second, you're shedding thousands of skin cells, dead skin, from your body into the room. And when you walk through a room and there's a sunbeam coming through the window and it's lighting up and you can see the sunbeam with all these particles, you are walking through not just you, Dan, but also all the people you live with. So you are breathing in all the people, past and present, actually. And over a lifetime, it adds up to kilograms of dead people that we're living in. And the microbial world know this. And so we are festooned with bacteria that are very good at eating that stuff. So skin is turning over at a ferocious rate. And this means that even though you may rub bits of it off, it replaces itself incredibly fast and it's very responsive and reactive. So if you have an area of skin that becomes damaged, it knows it's been damaged or it's been eroded, and it augments the activity of a population of stem cells that live below the skin, because the top layer of skin, that's all dead. The skin cells are flat, dead and dried out and just stuck together like a hard leathery layer. Deeper down in the skin, that's where the living cells are, stem cells that make new skin, and they can wind up and wind down their activity according to how much skin you need to make. So yes, you can exfoliate yourself to the point where you've removed a lot of skin, but you will grow it back, thank goodness.
Okay, so if anybody was thinking of committing crimes and removing their fingerprint tracing, it's not effective whether or not
You'd have to damage the stem cells right deep down to stop the skin regenerating if you wanted to do that.
No more advice for criminals. Thank you very much. We're on Cape Talk on a Friday. This is The Naked Scientist. My name is Dan Corder, in for Clarence Ford. We have a voice note from Lois for The Naked Scientist.
Hi, Naked Scientist. So we have a dragon fruit. It's planted in a pot and it is underneath the roof of our deck, which has a beam running across it. And all the other dragon fruits in the garden, they go like their normal way. But this dragon fruit has shot straight up all on its own without any support, and it's gone straight towards the beam. What I want to know is, how does it know? Because it's a plant that needs to attach itself to something and then like creep and hang over. How does it know the beam is there? And how does it know to grow straight up and find the beam? Because it doesn't have eyes and it doesn't have a brain.
Over to you, Dr. Chris.
Thanks, Lois. Now, plants, you said they don't have eyes, but they do have ears, remember? Boom, boom. If you go to a plant a field full of corn or barley, there are plenty of ears there. They can hear. I'm just joking. Prince Charles used to famously talk to his plants, and people have actually done studies to see if plants are sensitive to sounds, and the results are not compelling. Someone also I interviewed once had done the experiment where they were trying to train plants, so they'd have a plant with a fan blowing over it and a plant without a fan blowing over it, and they gave it various inducements to see if it would respond to and learn that under certain circumstances it should grow a certain way, and that didn't work compellingly either. But plants definitely do what they do very well. They grow roots down, shoots upwards, and shoots towards the light. So they actually can see, in inverted commas, and they can also feel gravity. And we know this because plants have actually been grown in space, where they grow in a very extraordinary and weird way. And I actually interviewed somebody from NASA called Volker Kern. This is about 20 years ago, when if you remember, the Columbia space shuttle unfortunately had an accident and it disintegrated when it was trying to return to Earth. And aboard that spacecraft were some experiments, and some survived, and they recovered some of the things. And one of them was an experiment to grow moss in space. And this helped the scientists to discover that plant cells have inside the cells a structure called the cytoskeleton. And there are particles of starch bobbing about inside the cell, and they land under gravity on this cytoskeleton, deform it, and this gives the plant an idea, almost like a spirit level, of which way is up and which way is down. So plants do actually tell up from down because they have these pressure sensors inside the plant, not that dissimilar actually to a system that works in our own ears that helps us to tell whether we're going up or down or sideways. So that guides certain parts of the plant to grow in a certain way. Roots know where down is because they can follow that signal. Shoots know where up is because they follow the reverse of that signal. And then there are other drivers. Plants are obviously very sensitive to light, and they have a phototropism. And when light shines on one part of a plant, it induces the production, or in other cases suppresses the production of other growth signals. And this has the effect of steering the growth by laying down more cells on one side of the stem than the other side, and this pushes the plant to grow in a certain direction. And this is why you turn the pot plant round on the windowsill, because otherwise it will curve towards the light. Now, your dragon fruit, you don't say what the sort of anatomy of your decking is and that kind of thing, but if the plant's getting light from all angles, then there's no net light signal from any one direction, so it's going to follow the geotropism, the downward signal, and say, well, that's down, I'm going to go up, because inevitably light comes from the sky, I'm going to go upwards, I'm most likely to get more light up there.
The Naked Scientist, we've got a text in from Jan that I find very interesting. Hi, Dr. Chris and Dan. Wild and domestic cats over years have looked at patterns and stripes on their skins. All directions or none, the tails' stripes are always around and never along the tail. Can you explain that?
Probably because, and I don't know the answer to this, I'd have to have a look at this. I mean, cat patterning is really interesting, and it's both mathematically very interesting, but also genetically how it happens, and biochemically how those patterns form is very interesting, and people have spent a long time studying this. The tail is a sequence of segments down the body, and if you look at the anatomy of the tail, it's a sequence of bones which have then grown out as an extension of the spinal vertebral column, and we just don't have one, but some animals do, and they have bones a bit like the bones in our back all the way down the length of the tail. Now, if you look at a developing creature, look at a developing human, for example, as an embryo, we develop as a series of segments, and from the head to the tail end, there are these things you could draw stripes across us. And along those segments, the reason the body knows where to put things during development, and things in different parts of the body develop in different ways, like, for example, where your breasts are, you have that segment forms nipple tissue. That is under a different set of genetic instructions than hormones, which is why men and women both have nipples. So all the way down the body, it knows where it is down the body, and it's following a specific genetic set of instructions that correspond to that segment of the body. So I suspect that there's something about the patterning coding that knows what segment it's in, and also has the same manifestation that gives cats their interesting stripy patterns elsewhere on their body, and bring those two things together and you get that pattern. And it's going to be a ring around the tail because the tissue forms initially as a blob which rolls up like a tube. So you start as a sheet and you roll it round so the front meets the back, a bit like if I had a toilet roll. That's how the tissue forms. It's a bit like if you cut the toilet roll along one side, you can unroll it to make a flat piece of paper. You can roll the edges back together. That's how the body forms. It forms a tube by rolling up. Okay. And that's why you get a ring all around the tail. So I'm speculating. I'll take it away and have another think about it, but I think it's going to be somewhere along the lines of what I just said.
Okay. Then we got another one in from Chris. I know we don't have a lot of time left, and I want to get as many people's messages on the radio as possible. So Keith says, what is a hiccup? And is there a way to stop one? Because there are so many myths, and I personally am tired of turning upside down and trying to drink a glass of water and washing my face against my will.
The posh medical word is singultus for hiccup, and I think the world record-breaking bout of hiccups lasted something like 75 years or something like that. It's an American
No,
gentleman.
man.
And
When
he
did the
did
hiccups
not
start? How long
well,
did
when he was
live?
little. Well, it was little, obviously, and it did not respond to any of the normal mechanisms, including getting a fright, turning upside down, etc. Sometimes hiccups can be caused by certain drugs. Usually, they're a diaphragmatic spasm of your phrenic nerve, which originates from the top part of your spinal cord, but is controlled by nerve centers in your brain stem, which is the top of the spinal cord that connects your spinal cord onto your brain proper. And there are lots of collections of nerve cells there that do important tasks that we don't have to worry about. And there are pattern generators there that create the respiratory rhythm. And obviously we can surmount that and voluntarily breathe in and breathe out. That's how we talk and sing, for example. But it means that when you go to sleep, you don't have to worry about breathing. But because those nerve centers that do that control are very close to other regions that process things like excitement, arousal, fear, when certain things wind up those other nerve centers, the activity in those centers can spill over into the respiratory areas, causing these diaphragmatic spasms down the phrenic nerve. So you pull your diaphragm down, all of a sudden drawing air in, and if your vocal cords are together, you pull the air in and suddenly your vocal cords close and the air all rams into them and you get a noise.
I see. Okay, that's so interesting. Then we got a voice note from Shireen. A lot of us are suffering this very personally right now. The mosquitoes are out and about and taking names. Let's get Shireen on the radio.
Good morning, Dr. Chris. My question is, can mosquitoes see when you're looking at them? You know, when you have that single mosquito that's bothering you, and every time you look away, and then it's back at you, but if you look at it, it will never come. It doesn't matter how long you wait for it.
knows.
Shireen
It knows,
from Ireland.
yeah. That's a great one. Thanks, Shireen. Well, mosquitoes can see, they do see, but they are far better at finding you using other detectors. They have antennae which are festooned with chemical receptors that can smell a raft of different chemicals, and those are our breath and the carbon dioxide we exude, other volatile chemicals coming off our skin, and they can also sense heat. So they home in on us using all of those mechanisms to find us. But it's likely, because they know that they're very vulnerable when they're feeding, and it's only the female ones that do this, and they do it when they're going to make eggs because they need the protein in blood. But they know they're at their most vulnerable when they're feeding because you could splat them. So they are very sensitized to any kind of stimulus that says you might be onto them. So when your breath pattern changes, when you swing round to look at them, you're going to move your body, you're going to move the air around, you're going to breathe at them, and all of these things may change the airflow and that kind of thing, and they're sensitive to that, and they may well take alarm and disappear or change their trajectory, and that way they try and avoid you getting onto them. But you're quite right, they are the most irritating thing, and especially at night when they seem to know where your ears are above all other
Yes.
structures on your body.
The thing that always makes me panic is the very simple thought, and it's an intrusive thought that I had, and I just realized I've never vocalized to anybody. Is I'm just scared that one day the mosquitoes will have a meeting and go, "Hey guys, if we just walk instead of flying, they won't know that we're coming. We will have such a good time. I just need the mozzies not to decide to walk." That would be great. Naked Scientist returns next week, Friday, with Clarence Ford on Views and News from 9:30. Dr. Chris, what a pleasure. Have a gorgeous weekend.
And you. Bye, Dan.